strain. It's the change in a dimension divided by the dimension itself. So if you wanted to express it in algebraic terms, it would be delta S divided by S. And the units are then unitless because we have a linear unit divided by another linear unit. So let's say delta S divided by S. The S is then the length between the two anchor points, and the delta S is the extensometer measurement differences. So you take a reading in one campaign, a second reading, take the first one away from it, and that's delta S, a change in the distance. So you just do the propagation, take the partial of the expression with respect to S and with respect to delta S, and what you find is that the propagation is less sensitive to the uncertainty in the overall distance because it ends up with a denominator that's S squared because it's initially in the denominator to start with. So that means that the sensitivity is more with respect to the uncertainty in delta S than it is with S. Now, typical extensometer can measure to 0.05 of a millimeter, and if we have points that are 4 millimeter or 40 meters apart, then we can figure out the propagation through, and it should be something in the order of 1 part per million or so, which in terms of other units which are maybe more in keeping with the use of an extensometer and calculation strain, a part per million is the same as microstrain, the little Greek letter mu with the word strain after.
Hopefully we can squeeze this one in. I've also been asked about study question number 12.
But maybe before I go on to that, I just want to be sure that everyone is aware of what's in store for the next session, which is on the 10th of September. We'll deal with the remaining topic, which is underground surveying, and we have the references that are listed there. And I would suggest that you approach it in the order that they're given. And then the study questions that are listed. And I think on your version it's on to the next page. And we'll probably have a bit of time left over where we'll just generally deal with the exam in general or any other concerns that may arise as you're going through this material. So, study question 12. Okay. The preamble to it here is very similar to the discussion that I gave earlier with respect to that one examination question to here. Now, how can we do repeated geodetic observations to describe tilt? And there's an example of this done in Jernowski's paper from 1993, which I mentioned to you was the one that was written for civil engineers. If we take 2 points that are benchmarks, they have a certain horizontal separation. And in this particular instance, they're 20 meters apart. And if we do repeated levelings, that means that we can, well, we assume then that we can set up the instrument midway between the two. So we have 10-meter lengths of sight. We do a measurement, back sight minus foresight, and if it's with an N3, then we're using double-scaled invar staves and doing it then twice, back sight minus foresight twice in each campaign. We can then end up with, let's say, a delta H between the two benchmarks. We come back at a later date and do the same thing. So we have a second value for the delta H. So if we take the differences, or sorry, the difference between those two delta H's, say the second delta H minus the first one, we have what we call delta H, the difference in the height difference between the 2 points. If we then take that difference and divide by the horizontal separation between the two benchmarks, That's basically a little bit of an arc subtending a distance, and we can then call that tilt. And of course, if we take delta delta H over, say, S, the distance, that will be in radians, and we can convert that into arc seconds by our friend 206.264.8. So now it's a question of looking at the instrument and coming up with how well can we figure out this delta delta H. Because again, it's similar to the extensometer business. If you do the full propagation, you see that the uncertainty in the distance doesn't have much influence because it's in the denominator and squared as a coefficient. So our main concern is the uncertainty in the delta delta H, the difference in the height difference divided by the S. So realizing that we're using an N3 and with sight lengths of 10 meters, we have a pointing and reading error combination, and we have a leveling error influence, and the two of those together provide us with the ability to determine the height difference backsight minus foresight. This is done twice, so we end up with an uncertainty in the height difference in any one particular campaign of no worse than 0.035 of a millimeter when we do that. If we then realize that the difference between the two is going to be then root 2 larger because we're taking delta H1 or delta H2 minus delta H1, then we multiply the 0.035 by root 2 and we get 0.049 millimeters. And then if we take the 0.049 millimeters, which is now our sigma delta delta H, divide by the 20 meters and convert it into arc seconds, we get half an arc second. So basically, and this is what point was made in Chernovsky's paper of 1993, we can use a high precision leveling instrument as a long base tilt meter. So if we have benchmarks that are within a reasonable distance apart, because in most instances we would want the lengths of sight to be somewhere in the order of 10 or 20 or at most 30 meters. And this would be typical in, say, a generating station. We can get the relative vertical movement of the two benchmarks, but knowing the spacing between them, we can also get the tilt, which for some engineers is of interest. And the advantage in this, the advantage in this is that when we look at the calculation of delta delta H divided by S, the uncertainty in the horizontal distance can be quite large. We don't have to know that all that well because of the way the propagation through. Same as with the extensometer and knowing the actual distance between the two anchor points. It's the same type of propagation.
All right, I'd like to thank everyone for attending the third of 4 webinars on the C3 Advanced Surveying exam. The next one is scheduled for August 27th, again at the same time as today. August 27th is today. September 10th. September 10th at the same time as today. And is the same as this one. You'll receive an email invitation, and you'd use the same process to register for it. So I'd like to thank you for attending. I'd like to thank James for his presentation. And oh, actually, hold on. It looks like we have one more question before we go. Is the guide shown available on the website?
This is a version that came out this past June.
Yep.
And it's been on the CBEP's website since then. So there's the learning outcomes have been revised a little bit, and the study guide was revised a little bit because there were quite a few typing errors that resulted when it was converted by somebody before it got onto the website. So I've changed that so everything is now legible and maybe a little more easily understood.
Yeah, and you should be able to. Yeah.
Some of the reference materials also available on the CBEP's website.
That
was recently revised too.
Yeah. On the CBEP's website, under the Study Resources tab, you should be able to find everything. All right. I will bring everything to a close now, and thank everybody for their questions.